Hello everyone and hello to my lecturer, Madam Zatia Halwani. Before we get started, let's meet our group member. The first member is me, Noor Safira, and the second one is Izzati Liana, and the third is Siti Suraya.
So now I will start the presentation with introductions. Okay, refer to the questions that have been given to my group are below the topic Derivative of Functions Trigonometric, which is under the title Chapter 2, Differentiations. Okay, the first one is the trigonometric functions is the mathematical process of finding the derivative of a trigonometric functions or its rates of change with the respectively to the variable angle. The second is the differentiations of trigonometric functions can be done using the derivative of sin x and cos x by applying the quotients rule. Besides that, the basic trigonometric functions include the following six functions, which is sine, cosine, tangent, cotangent, secant, and the last is cosecant. All these functions are continuous and differentiable in their domains. The differentiation formulas of the six trigonometric functions are listed below. So, as we can see in the slide is a table which shows the formula of the six trigonometric functions. So, in this table, we can see that have names, abbreviations, and ratio. Let's continue with important applications derivative in mathematics. The first one is rates of change of a quantity. Second is increasing and decreasing functions. Third is tangents and normal to curve. Fourth is minimums and maximum value. Fifth is Newton's method. And the sixth is linear approximations.
Derivative is not only can be used in mathematics, it also can apply in real life, such as to calculate the profit and loss in business using graph. It also can apply to check the temperature variation. It also can be used to determine the speed or distance covered, such as miles per hour, kilometer per hour, or else. Derivatives also can be used to derive many equations in physics. In the study of seismology, derivative can used to find the range of magnitude of the earthquake. Problem statement. An airplane flying at 450 km per hour at a constant altitude of 5 km is approaching a camera mounted on the ground. Let theta be the angle of elevation above the ground at which the camera is pointed. When theta is equal to pi over 3, how fast does the camera have to rotate in order to keep the plane in view?
Okay, for the solution, the first step is we need to do some sketching based on the information that we get from the equation. The speed of the plane can be symbolized by dx over dt is equal to 450 km per hour. Now we need an equation that relates our variable to one another. Here, the most efficient possibility turns out to be the cotangent function. I choose cot to solve this question. Okay, cotangent is the opposite of tangent, which is cot theta is equal to adjacent over opposite. Look at our sketch again. 5 km is the opposite of the angle pi over 3, and this I call this as A. A is the adjacent of the angle pi over 3. The next thing we need to do is to differentiate this equation. Cotangent of pi over 3 is equal to 1 over 5. I let the adjacent of the angle become 1 so that I could take the derivative more easily. Okay. When we do the derivative of cotangent of theta, we know that it was equal to negative cosecant square theta. We are going to use the chain rule and multiply by the derivative of the d theta over dt, and over here we have a 1 over 5x. Again, we are doing the derivative with respect to the time, and derivative of 1 over 5 would be multiplied to the dx over dt, which equal to 450 km per hour. So over here, we are going to just plug in the value. We know that theta is equal to pi over 3, so plug in the value, we get negative cosecant square of pi over 3 multiplied by d theta over dt, which equal to 1 over 5 times 450 km per hour. So to solve this, we could simply multiply both sides of the equation to the 5 over 1. So 1 is cancelled, 5 is cancelled, so we get 5 times negative cosecant square of pi over 3 multiply d theta over dt, which equal to 450 km per hour. Here is when we need to figure out what is the negative cosecant square of pi over 3 is. Okay, let's talk about that. Okay, we know that cosecant square of pi over 3 is equal to 1 over sin pi over 3. Okay, we know that pi over 3 is equal to 60 degree and sine 60 degree is equal to root 3 over 2. Okay, so I got this equation, like I got 1 over root 3 over 2. Okay, to solve this, we could basically reciprocating it to 2 over root 3. Okay, since cosecant is square, so we imply the square to the both side, and we got 4 over 3. Okay, and then we plug in the value of 4 over 3 into the equation that we get just now. Here, 5 times negative 4 over 3 times d theta over dt, which equal to 550 km per hour. So 5 times negative 4 over 3 is we get negative 6.67, which multiply to d theta over dt, which equal to 450 km per hour. So we put the negative 6.67 to the other side, so it becomes a positive, and 450 km divided by 6.67, we get 67.47 radian per hour. So that is our final answer of this question.
So, for the conclusion is, the camera need to rotate 67.47 km per hour in order to keep the plane in view. We can apply the derivative of function to solve the problem that involve the rate of change of something by differentiate the equation by using the chain rule.
Here is our reference. Thank you for watching our video.